Using 14.3 cable for smoke detectors can be more efficient, but it is not inherently faster. The time savings would be minimal. Using 18.2 stat wire for interconnects is acceptable, as it is commonly used for this purpose. It is not advisable to have two breakers feeding one side of the home. This can create safety hazards. Tracing the tie-in point for this issue is crucial for ensuring proper electrical functionality and safety. The self-stripping type connections and the plug-and switch assembly are designed for faster installation. However, it is important to ensure that the connections are secure and made properly. Testing electrical components with 1080 volts is done to ensure their insulation and safety. This test is typically conducted by the manufacturer during production, not during installation. The final inspection authority for electrical installations typically varies depending on local building codes and regulations. It is usually a licensed electrician or electrical inspector who has the authority to approve or disapprove the installation. Contact the local building department or electrical inspector to clarify the final inspection authority. Trace the tie-in point for the two breakers feeding one side of the home and correct the issue. Inspect the smoke detector wiring to ensure all connections are made properly and securely. Consider using a more secure method for plug-in switch connections, such as wire nuts. The National Electrical Code, (NEC), provides comprehensive standards for electrical installations to ensure safety and proper functionality. Article 210.8 covers ground fault circuit interrupter, or GFCI, protection, specifying locations where GFCI protection is required to prevent electrical shock hazards. For example, GFCI protection is generally required for receptacles in bathrooms, kitchens, garages, and outdoor locations. Article 250 provides detailed requirements for grounding and bonding, which are essential for creating a safe electrical system. Proper grounding ensures that fault currents have a low impedance path back to the source, allowing overcurrent devices to trip and clear the fault. Bonding connects non-current carrying metal parts together to minimize voltage differences and prevent shock hazards. Article 300 addresses wiring methods, specifying how conductors should be installed and protected. It covers topics such as conduit fill, cable support, and protection against physical damage. Proper wiring methods are crucial for preventing insulation damage and ensuring the long-term reliability of the electrical system. Article 310 covers conductors for general wiring, including ampacity ratings and installation requirements. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. The NEC provides tables, such as Table 310.15b16, that list the ampacity of conductors based on their size, insulation type, and ambient temperature. Article 400 covers flexible cords and cables, specifying their permitted uses and installation requirements. Flexible cords are commonly used for connecting portable appliances and equipment. The NEC limits the use of flexible cords to prevent them from being used as a substitute for permanent wiring. Article 404 addresses switches, including their installation and wiring requirements. Switches must be rated for the voltage and current they will be controlling. The NEC also specifies requirements for switch boxes and faceplates. Article 406 covers receptacles, including their installation and wiring requirements. Receptacles must be rated for the voltage and current they will be supplying. The NEC also specifies requirements for receptacle spacing and GFCI protection. Article 408 addresses panel boards, including their installation and wiring requirements. Panel boards are used to distribute electrical power to branch circuits. The NEC specifies requirements for panel board location, overcurrent protection, and grounding. Article 430 covers motors and motor circuits, including their installation and protection requirements. Motors can draw high inrush currents during startup, so they require special overcurrent protection. The NEC provides detailed requirements for motor circuit protection, including overload protection and short circuit protection. Article 500 through 516 cover hazardous locations, specifying requirements for electrical equipment installed in areas where flammable gases, vapors, or dust may be present. These locations require explosion-proof or intrinsically safe equipment to prevent ignition of the hazardous substances. Article 547 addresses agricultural buildings, specifying requirements for electrical equipment installed in areas where livestock are housed. These locations can be corrosive and require special wiring methods and equipment to withstand a harsh environment. Article 680 covers swimming pools, fountains, and similar installations, specifying requirements for electrical equipment installed near water. These locations require special precautions to prevent electrical shock hazards, including GFCI protection and bonding of metal parts. Article 690 addresses solar photovoltaic, or PV, systems, including their installation and wiring requirements. PV systems generate direct current, or DC, electricity, which must be converted to alternating current, or AC, for use in homes and businesses. The NEC provides detailed requirements for PV system wiring, grounding, and overcurrent protection. When tracing electrical circuits, a systematic approach is essential to identify the source of the problem and ensure that the correct repairs are made. Firstly, gather information about the circuit's behavior. Talk to the homeowner or building occupants to understand the specific issues they are experiencing, such as lights flickering, outlets not working, or breakers tripping. This information can provide valuable clues about the nature and location of the problem. Secondly, create a circuit map. Obtain or create a detailed map of the electrical circuits in the building. This map should show the location of all outlets, switches, lights, and appliances, as well as the wiring pathways and the circuit breakers that feed them. A circuit map can be invaluable for tracing circuits and identifying potential problems. Thirdly, use a circuit tracer. A circuit tracer is an electronic device that sends a signal through a circuit, allowing you to identify the corresponding breaker or wiring path. These tools typically consist of a transmitter that is plugged into an outlet or connected to a wire, and a receiver that is used to trace the signal through the wiring. Fourthly, visually inspect the wiring. Carefully inspect the wiring along the circuit path, looking for any signs of damage, such as frayed insulation, loose connections, or burned wires. Pay close attention to areas where the wiring may be exposed to physical stress or environmental factors. Fifthly, check the voltage and continuity. Use a multimeter to check the voltage and continuity of the circuit at various points along the path. This can help you identify breaks in the wiring, short circuits, or other electrical problems. Sixthly, test the devices on the circuit. Test all of the outlets, switches, lights, and appliances on the circuit to ensure that they are working properly. If any of these devices are not functioning, they may be the source of the problem. Seventhly, isolate the problem area. Once you have identified the general area where the problem is located, try to isolate the specific section of wiring or device that is causing the issue. This may involve disconnecting wires or removing devices from the circuit to narrow down the source of the problem. Eighthly, make the necessary repairs. Once you have identified the source of the problem, make the necessary repairs. This may involve replacing damaged wires, tightening loose connections, or replacing faulty devices. Ensure that all repairs are made in accordance with the National Electrical Code and local built-in codes. Ninthly, test the circuit again. After making the repairs, test the circuit again to ensure that it is working properly and that the problem has been resolved. Use a multimeter to check the voltage and continuity of the circuit, and test all of the devices on the circuit to ensure that they are functioning correctly. Finally, document your findings. Keep a record of the problems you found, the repairs you made, and the results of your testing. This documentation can be helpful for future troubleshooting and can also be used to demonstrate compliance with safety regulations. When working with electrical systems, it is important to take precautions to protect yourself from electrical shock and other hazards. Firstly, always disconnect the power. Before working on any electrical circuit, always disconnect the power at the circuit breaker or fuse box. This will help prevent electrical shock and other injuries. Secondly, use insulated tools. Use tools with insulated handles to protect yourself from electrical shock. These tools are designed to prevent electricity from flowing through your body. Thirdly, wear safety glasses. Wear safety glasses to protect your eyes from flying debris or sparks. Electrical work can generate small particles that can cause serious eye injuries. Fourthly, wear rubber gloves. Wear rubber gloves to protect yourself from electrical shock. Rubber gloves provide an additional layer of insulation between you and the electrical circuit. Fifthly, work in a dry area. Avoid working in wet or damp areas, as water can conduct electricity and increase the risk of electrical shock. Sixthly, use a ladder safely. If you need to work at heights, use a ladder safely. Ensure that the ladder is stable and that you are using it properly. Seventhly, be aware of your surroundings. Be aware of your surroundings and avoid touching any metal objects while working on electrical circuits. Metal can conduct electricity and increase the risk of electrical shock. Eighthly, get help if needed. If you are not comfortable working on electrical circuits, get help from a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary knowledge and skills to do the job safely. Finally, follow safety regulations. Follow all safety regulations and guidelines when working with electrical systems. This will help ensure that you are working safely and that you are not putting yourself or others at risk. The proper use of wire connectors is crucial for making safe and reliable electrical connections. Firstly, choose the right size connector. Select a wire connector that is appropriate for the size and number of wires you are connecting. The connector should be able to accommodate all of the wires without being too tight or too loose. Secondly, strip the wires properly. Use a wire stripper to remove the insulation from the ends of the wires. Be careful not to nick or damage the wires, as this can weaken the connection. Thirdly, twist the wires together. Twist the stripped ends of the wires together tightly. This will help ensure a good electrical connection. Fourthly, screw on the connector. Screw the wire connector onto the twisted wires, turning it clockwise until it is snug. Be careful not to over-tighten the connector, as this can damage the wires or the connector. Fifthly, test the connection. After making the connection, test it to ensure that it is secure and that there is good electrical conductivity. You can use a multimeter to check the continuity of the connection. Sixthly, use the correct type of connector. Use the correct type of wire connector for the application. There are different types of connectors for different types of wires and different types of connections. Seventhly, follow the manufacturer's instructions. Always follow the manufacturer's instructions when using wire connectors. This will help ensure that you are using the connectors properly and that you are making safe and reliable connections. Eighthly, inspect the connections regularly. Inspect the wire connections regularly to ensure that they are still secure and that there are no signs of corrosion or damage. If you find any problems, replace the connectors immediately. Finally, use a torque screwdriver. Use a torque screwdriver to tighten the wire connectors to the proper torque. This will help ensure that the connections are tight enough to provide good electrical conductivity, but not so tight that they damage the wires or the connectors.